Video, I'm going to go over our second chapter 5 review, and this will be focusing on the lessons from 5.4 and 5.5. So the first lesson with 5.4 was focused on polynomial division. So I'm going to start with some questions on long division and then move to the quicker version, synthetic division. All right, so let's start with this first one here. I'm using long division to divide this cubic polynomial with 4 terms divided by 4x minus 3. So write 8x cubed plus 26x squared minus 12x and then minus 5. All right, that's divided by 4x minus 3. So the way that I was teaching you guys to do this in class was very similar to what you did when you did this in elementary school, right? The idea is I have to figure out how many times does 4x minus 3 go into this long polynomial. So it's a little tougher, but ultimately what I want your brain to think is there's some term that when you multiply it by 4x, right, this first term here, you're going to get the first term in the dividend. So I'm going to do, let's see, 4 times 2 gives me 8, and then x squared times x gives me x cubed. And you might be wondering why I wrote it there. I always like to write it above the same term that's below it in terms of the exponent. So it's x squared that matches the x squared below it. So multiply the 2x squared times 4x, you get 8x cubed. That shouldn't be a surprise. 2x squared times negative 3 is minus 6x squared. And then we're going to subtract. When you subtract, you get 0 for the first term. 26x squared minus a negative 6x squared is really addition. So that's going to be 32x squared. And then bring down the remaining terms that you haven't touched. Repeat the process. So I'm thinking something times 4x gives me this first term, 32x squared. So I know it's going to be a positive 8. And then x times x gives you x squared. So that's 32x squared. 8x times negative 3 is negative 24x. Make sure you do subtraction for long division. So that's going to be 0 for the first one. Negative 12x minus a negative 24x is really adding 24x. So that's going to be positive 12x. And then bring down the minus 5. Last time, hopefully we have to do this. So 4 times 3 is going to give me 12. And I don't need to put an x because it just has the x is already there, so I don't need to put anything else. So 3 times 4x is 12x. 3 times negative 3 is minus 9. All right? So when I finish the subtraction, a negative 5 minus a negative 5 is really, minus a negative 9 is really adding 9, so that's going to be 4. All right, so this is all the work. Let's write down the answer. I don't mind if you just write, up here, plus 4 over the divisor. I'm going to write it down here, though, again, as the answer. So 2x squared plus 8x plus 3. And then I'm going to write plus 4 over 4x minus 3. So this whole thing is our quotient. All right, so that's long division. Let's do another one with long division. So we have 2x cubed minus 6x squared plus x plus 9 divided by x plus 1. Okay, so same process. Something times x is going to give me that 2x cubed. So I'm going to do 1 times 2 gives me 2. X squared times this x gives me x cubed. All right, multiply the 2x squared times the 1. We're going to subtract. It'll be 0 in the first one, right? That's on purpose. Negative 6x squared minus 2x squared is negative 8x squared. Bring down the plus x and the plus 9. Repeat. All right, so to get negative 8, I need to multiply by minus 8, and then x times x gives me x squared. Negative 8x times 1 is negative 8x. Subtract. You're left with 1x minus a negative 8x is really plus 8x. So that's 9x. And then repeat it. I need to multiply by 9. 9 times x is 9x. 9 times 1 is 9. When you subtract, you get actually 0 for both of these things. So you have no remainder. So this in red at the top is my answer. That is my quotient. I'll copy it again. 2x squared minus 8x plus 9. If you want to write plus 0 over that divisor of x plus 1, go for it. It's not necessary because the remainder is 0. All right, so that's it for our 2 long division questions. Let's move to synthetic division. So hopefully you'll find this to be a little bit quicker. Remember, the way to do this is you take all of the coefficients, including their signs, right, and write them down. So 2, negative 21, 8, 18, and 20. I always check to make sure that I didn't skip any, right? It goes 4, 3, 2, 1, and then the constant. All right, so I don't need to worry about any placeholders. In the corner is where I do the opposite of what I see for my divisor, x minus 10. So I'm thinking the opposite of minus 10 is actually a positive 10. All right, and then draw that line to start the process of synthetic division. Bring down the first number here of 2, multiply that 2 by the number in the corner. 2 times 10 is 20. Now, this is different than long division, right? This is our synthetic or fake division. So we're going to be doing addition as you move down in the columns. So negative 21 plus 20 is negative 1. Repeat the process. Multiply by the number in the corner. All right, I'm going to add. Repeat. I'm going to add. Oops, sorry. And then multiply by that number in the corner and add, and you get 0. So since I got 0, right, I'm not going to have a remainder. But the hardest part is students will just stop here and won't write the answer. Remember to write the solution. Look at the highest exponent at the beginning. It's going to be 1 less is going to be your highest exponent in your answer. All right, so this 2 to start is going to be 2x cubed minus 1x squared minus 2x. Try the writing this again. Minus 2, and then if I had a remainder, I would write plus that remainder over the divisor, but I don't. So this is my quotient. That's synthetic division. Let's do one more synthetic. All right, so I've got 1, negative 1, negative 12, and negative 5 from my coefficients here. All right, the number in the corner, think opposite of plus 2 is negative 2. And then start the process. So bring down the 1, multiply by the number in the corner, add. Negative 3 times negative 2 is 6. Add, you get negative 6. That's positive 12. And then add, you get 7. So this is not going to have, it's going to have a remainder. So remember, we started with 3 when I saw this, x cubed. So this 1 is going to start as 1x squared. You can write the 1 in front, but I'm not going to do that. So it's just 1x squared minus 3x minus 6, but don't forget the remainder this time, plus 7 over x plus 2. That's the divisor. All right, so that is synthetic division. Okay, let's move to our next lesson, 5.5, which started talking about how to find the real solutions when you're given the graph of a function. This hopefully is pretty straightforward. You're just going to look for the x-intercepts. I see one at negative 6, at negative 2, and the origin, 0, 0. So I'm going to write down the x-intercepts. And you can write down x equals these numbers. You can write down ordered pairs like I do. I don't care. It's your choice. So negative 6, 0, and then negative 2, 0, and 0, 0. All right, and this is it. This is the answer. That's all I needed you to write. It is nice to make sure you know, like from the last review, which are single, which are double. So just looking, you can see that this one here at negative 2 is interesting because it touches, it doesn't cross. So that would be our double root. Don't need to write that for these questions, though. Same thing, negative 8, negative 2, positive 4. So I'll try this way. So I have x-intercepts at, and I'll write down my x's. So x equals negative 8, x equals negative 2, and x equals positive 4. Now, I don't see anything interesting in terms of these roots. They all just cross normally. So these would all be single roots. All right. What's going to happen when I do this on the test is students are going to forget like when you think opposite. And these questions, you'll notice I'm not thinking opposite for 5 or 6. I'm just writing down the x-intercepts either as ordered pairs or just list them out. when you get to those questions that we did in the first review, where you had to actually write the function in that root form, that's when I was thinking opposite. But in this case, not thinking opposite here. Okay, the last three. This is where I'm going to be given the actual function, so I don't know the graph of it, and I'm going to be asked to use some algebraic skills like factoring to find the x-intercepts. So the first step is always to set your function equal to 0, right? The idea here is that if you're finding x-intercepts always have y values of 0, so I need to figure out what values for x are going to make the y value become 0. Now, this one, I don't have any common factors to take out of all four of these terms. So this is where I'm going to recommend that you factor by grouping, right? And this is a skill you need to know, so I'm going to ask this for sure on the quiz and the test. So I'm going to factor out what's in common in this first group, which is x squared, and the second group, which is a minus 4. Now, you'll notice when I factor those out, to get the stuff that's in the parentheses, you're really just doing division, right? X cubed divided by x squared is x. All right, same thing. Negative 3x squared divided by x squared is negative 3. Negative 4x divided by negative 4 is 1x. 12 divided by negative 4 is negative 3. Right, so that's kind of the step-by-step process there. Hopefully, when you do this, you'll notice that the inside the parentheses are the same, right? These are the same, so they share this factor. It's a common factor. So I'm going to take the x squared and the minus 4, the stuff that I factor out, and that's going to make a factor. And then I'm just going to bring down 1x minus 3 because they have it in common. Don't bring down 2 of them. Just bring down 1. This is almost it, but this x squared minus 4 is the difference of two squares, which factors as x minus 2 and x plus 2. So here we go. This is fully factored now. So I can write down my answers. Remember to write down the answers that are going to make them 0. So I have to think opposite. So 2 minus 2 is 0. Negative 2 plus 2 is 0. And 3 minus 3 is 0. So these are my 3 x-intercepts. All right. Let's try to find the same thing for number 8. Set it equal to 0. Now this one, it looks like, there we go. You do have a common factor. I can't factor out a number, right, because this is a 1. But it looks like they all have that variable x. And you want to factor out up to the lowest one, which would be x squared. So if I factor out x squared, I get x squared minus 8x plus 16. All right, so I'm going to just keep copying down that x squared. Let's try to do this factoring like you did in Algebra 2. Do you know factors of 16? Right, so factors of this 16, they're going to add to negative 8. So I need two numbers that multiply to give me 16 and add to negative 8. I think that's going to be negative 4 and negative 4. So if you wanted to write this as x minus 4 raised to the second power, you could because they are the same. And I don't need to write the answer twice when I look at my solutions here for my x-intercepts. So I just need to figure out what's going to make each of these 0. Right, 0 squared is 0. And then 4 minus 4 gives me 0. So I only have 2 answers, right? But you might be wondering, hey, how come I only have 2 when the degree was 4? Well, both of these are double roots because they come from factors that are squared, right? I know I didn't write x minus 4 squared, but there's 2 of them. So hence the double roots. Okay, last one, number 9. Set it equal to 0. All right, let's see if we can factor out anything. I'm going to factor out this negative. It's a negative 1, so I can't factor out a number, but I can factor out x squared. When I factor out that negative x squared, I get a positive x squared that's left. And then this actually needs to become a minus, right? Because a positive divided by a negative is a negative. The x squared divided by x squared is going to be 1. So I just need to have that 49 that's in there. And I know it's been a while since you've done this in Algebra 2, but I need your brain to know that this is a special case. It's called the difference of two squares like we had a few questions ago. Right? If you're having trouble with that, you can always just ask yourself, what are two numbers that multiply to give you negative 49, but add to give you 0? Right, on number 8, right, this said negative 8x. It wasn't a 0, right? So negative 4 plus negative 4 gave us negative 8. But on this case, since I don't have an x term, and I just see x squared and the constant, I need to think of two numbers that multiply to give me negative 49, and add to 0. Or you can think, what's the square root of 49? It's 7. Make 1 a positive and make 1 a negative. So when I write down my solutions, you don't need to worry about that negative. I just care about the x that's being squared. 0 squared is 0. The opposite of positive 7 gives us negative 7. And the opposite of minus 7 gives us a positive 7. So these are the 3 solutions for this one. Again, you're like, wait, there's only 3 solutions, but there was a 4 there. That's because of this square. So that x equals 0 is what we call a double root. Yes, we did it, guys. That's it for the review number 2. Good luck on this quiz and good luck on the test.